Hey math students, so we're continuing with this function problem. We have a rational function and we're continuing down our list of needed information or our key characteristics. So we're going to jump into horizontal asymptote. Now to me, horizontal asymptote is kind of not necessarily a tricky one, but it is the one that has two options that we have to choose from based on which one fits our function. So there are two situations that we need to read through. So the first situation, it says if the degree is higher in the denominator, the horizontal asymptote occurs at y equaling 0. So for the horizontal asymptote, we are comparing the degree of the numerator with the degree of the denominator. So again, in the second one, it says if the degree is the same in the numerator and the denominator. So here we want to compare the degree of both the numerator and the denominator. So if I were to look here, we are given a function in factored form, but I should know the degree based upon how many factors we have and the multiplicity of those factors to kind of bring forward some of that math vocabulary. Another way of thinking about it is if I had this x and it were to multiply with this x and it were to multiply with this x, what is the degree or the exponent for all of those x's that would be multiplied? So x times x times x, I would have had an x cubed in the numerator, and then x times an x, I would have an x cubed in the denominator. So hopefully you're able to identify how we found that the degree is both 3 in the numerator and the denominator. And this is actually referring to our second one. So the first one, it says the degree is higher in the denominator. That is not the case. We have the same degree. So here we're choosing the second option for our horizontal asymptote. And it says if the degree is the same in the numerator than the denominator, the horizontal asymptote equals the quotient of the leading coefficient. So the quotient is just the ratio or the fraction. So again, just like we said, if it's x times x times x is how we got x cubed. Well, what about those coefficients? So in this case, all of my coefficients are 1. I have a 1x here, a 1x here, and a 1x here. So it's really like I have a super secret 1 right here. We just don't write it because like we're kind of lazy. But there is a leading coefficient of 1. And then same thing in the denominator. 1x times another 1x times another 1x. All of those 1's multiplied together would give me a leading coefficient of 1. So if I took the ratio, or they say the quotient of those, I would have 1 over 1, which gives me obviously 1. So my horizontal asymptote, oh, I almost wrote 2/5 because that's what they have here in the example, but it should just be 1. So I have a horizontal asymptote of 1. Okay, and then I'm going to deviate away from this, but we're going to revisit some key characteristics that we've always looked for in any type of graph, and that is going to be the intercepts. We'll start with the x-intercept and then move on to the y-intercept. Okay, as you know, an x-intercept is where this graph crosses the x-axis. For a point to be on the x-axis, y must equal 0. That is the only way for it to cross the x-axis. So if I know that my output or my y value is 0, I can replace my output, in this case it's written as f of x, in my function. So I'm going to have 0 is equal to x minus 5. So I'm just going to rewrite this entire function all over to x minus 3, x plus 1, x minus 1. Okay, and then now I'm going to solve for x, which you're probably maybe looking at that and being like, ew, gross, I hate fractions. Okay, if you're that person that hates fractions, then get rid of them. All this fraction means is to divide. I know how to get rid of division. I'm going to just multiply. So I'm going to multiply by the thing that is causing that division, which is my denominator. So I'm going to multiply by x minus 3, x plus 1, and all of that x minus 1. So, no, I didn't quite leave myself enough room, but what I do to one side, I do to the other side. So I'm going to multiply this left-hand side as well. Okay, looking on the left-hand side, if I have anything, including all three of these factors multiplying with 0, anything times 0 is still going to be 0. So then now on the right-hand side, the whole point of that multiplication was to cancel out with my division. So all of that cancels, just leaving me with my numerator factors. And then now this is exactly how we've been solving factored polynomials this entire quarter. So we can now separate out each factor, set them equal to 0 to solve for its corresponding x value. But I will point out that this x equaling 1, we already found something about this value of x equaling 1. What did we find out about that? This x equaling 1 is a whole. So it's actually not an x-intercept. This is a hole in the graph. And again, I'll show you what that looks like visually when we look at the graph in Desmos. So now we're going to quickly look for the y-intercept, which occurs when x is equal to 0. So if x is equal to 0, I'm going to replace all of these x's with 0 and solve for the output. I'm going to use y for the output just because I'm kind of being lazy and don't want to write a bunch of f of x. 0 minus 1 all over 0 minus 3, 0 plus 1, and then I'm 0 minus 1. Okay, just simplifying, following order of operations, complete the operation in each parenthesis. So I'm going to have a negative 5 that is multiplying with a 2 that is multiplying with a negative 1. Then I'm going to have this negative 3 that is multiplying with a 1 that is multiplying with a negative 1. So if I were to multiply the top, it looks like I would get a 10. And then if I had to multiply the bottom, it looks like I get a 3. So my y-intercept, my x-coordinate has to be 0. That is the definition of a y-intercept, followed by the corresponding y value. So that is how I would find all of that information. But as I said, let's look at how this graph looks in Desmos. So here I have typed in that function. I can see my y-intercept that I just found. They changed it to a decimal for me, but that's fine, 10/3. I can see my first x-intercept at -2, my second x-intercept at 5. But remember, we had that hole. X equaling 1 was that hole. So if I wanted to find my x equaling 1, I can just kind of see if I can trace along here. Oh, it was just right there. Where were you? Come back. See that? 1 is undefined. See how that's an open circle and that I have a closed circle? But as soon as I move to an x equaling 1, it is an open circle, which mathematically shows that it does not include that value of 1 in this graph. This kind of U shape at the very top jumps over that coordinate of x equaling 1. The other things that we found were the asymptotes. Desmos does not show the asymptotes automatically, so I typed them in for us. Here's my first asymptote, that x equaling 3. So I have that one showing here. And does it look like an asymptote? Remember, an asymptote is where these branches are kind of these parts of this function get really, really close to that line. It's approaching that line, but it doesn't cross. So even if I scroll up, yep, it's getting, that red graph is getting pretty dang close to that orange, but it doesn't really look like it crosses. So same thing with my other vertical asymptote at x equaling -1. And then I can tell the same thing with that horizontal asymptote of y equaling 1. I can move far out. That branch looks like it's getting closer and closer and closer and closer, but it's not touching that asymptote. So I hope that this clarifies how to find all of those key characteristics and how to visualize them on your graph. As always, if you have something that I can help with, reach out.